Good morning, everybody. Welcome to class with Professor Mead. Today we're going to talk about sampling design and sampling design approaches. So as I am lecturing here, you would want to think about what is going to work best for you and how you can talk about this with your partner. If you're working on this research project alone, you need to talk about this with another classmate who's working alone. It's vital that you verbally express your plan of action and try to talk this through so that when you sit down to write your plan of action for your sampling design and research design, it's coherent and it makes sense. If you don't talk it out verbally or try to explain it or think it through and just try to write it down, it comes out oftentimes as nonsensical. Okay, so you're going to start, if you're following along in the workbook, we're right around page 19. If your document hasn't moved around too much, so it's the sampling design. Anytime you see this little guy right here, the owl, he is telling you that you have your section of your paper due. And so where it says start sampling design here, you would start writing your sampling design. Each one of these sections is going to be pulled out and put into a full paper together if that's a requirement for your course. So within your sampling design, right, it is going to be a description of how you are going to collect your people, your target population, including when, where, how, all of those things. So think of the standard when, where, how, you know, and how you're going to collect the people to do research with, who it is you're interested in gathering data from. It should include your title as your research, your research question as your title, always. Your hypothesis, make sure they're labeled properly, and then your sampling design, which is a plan of action for collecting the participants. This owl right here, he tells you kind of how to, once you're done, how to grade it, right? So, you know, did you have your research question and a hypothesis? Is it logically connected, designed to the hypothesis and the question? So you just, you know, okay, is it an actual design? Sometimes people want to just answer the questions. That's not a design. You need to be telling me a plan of action, who your target population is, a census if that's available for your target population. If not, how you looked for it or why it's not available. A detailed description of your sample method, so how you're collecting those participants, the method you're using, what the size is of them, and you want to address any validity and reliability issues. So you need to know that information from the validity and reliability lecture from last lecture. So overall, what a sampling design is, it's a clearly and logically designed plan of action so that the reader could actually not just know what you were doing or what you're planning on doing to collect your people, but also so that if that person needs to replicate your research, they could do so. That's the way you should think about it. Okay, so before we get started, let's talk about the difference between a research design and a sampling design. So sampling design is a subcategory of your method section. Both the research design and the sampling design go within the method section. Let's start with the research design. The research design, now let's start with the sampling design. Sampling design is how you're going to collect your subjects, right? So who your subjects are, who your target population is, we'll explain what that means in a minute, and how you're going to collect that target population. So how you're going to target those people that have the specific information that you need, right? And then how you're going to address that reliability and validity issues in your population. So a sampling design is how you're going to collect your people. A research design is how you're going to collect your data, right? So you're going to explain in a research design, which we so you're going to collect in your research design like what type of data you actually are using. Let me start over here. So in your research design, what you want to convey is a plan of action for the data that you're collecting. So the first thing you want to think about is, how are you going to test your hypothesis? When you have an idea of what method is most appropriate for testing your hypothesis, remember the lectures on concurrent data collection, sequential data collection, right? All those mixed methods, triangulation, which one would be most appropriate for your research? What type of data collection? Is it surveys? Is it secondary data analysis? Is it content analysis? Those types of things. So I've kind of pushed everybody towards surveys, and that's actually what you're doing, which makes it a little bit easier. So you know there's a survey style. Mind you, interviews and surveys are not the same thing. Interview is kind of a general word, and a survey could be in an interview. My dog complaining. Come here. Stop whining. Stop whining. Here comes one. She's upset because we haven't gone on a walk yet, and he's upset because she's not playing with him. Okay, so let's get through this so that they can get their walk. They think that's more important. So what method are you using? You know, choose a mixed method, explain the mixed method, explain why you're using that mixed method, also called triangulation, right? What components are qualitative? What components are quantitative? Is it sequential? Is it concurrent? What methods of collection in detail are being used? And then how are you addressing the validity and reliability issues? So when we're doing this portion of the methods section, it's proposed, right? It's a proposals. So I am going to be using this method design. This part will be qualitative. This part will be quantitative. This particular, this will be surveys, in-person, written DCIs. People will be taking them, or I will be asking, I will have written survey DCIs, and I will be asking people over the phone and writing in the answers. You need to explain all of that. It needs to be such that if somebody were to come back who doesn't know you, doesn't know this class, they could replicate your research. That's the way you should think about it. Okay, so let's talk about some of the common language so that we understand it. It can be a little bit confusing because common language in research is a little bit different than common language. It can use the same words, but it's different, has a different meaning than the same word in everyday life. A good example of this is population. So population in everyday life simply means a census. It's a number, right? So the population of LA County is 10 million, right? In research, that's not what we're talking about. A population is the group of people who you are going to eventually target. So the group of people who have the characteristics that you need to be able to get the information that you need from them, right? So if you want to talk about, or if you're doing research on how people feel about other people with tattoos, right? You might have a population or people in Orange County and how they feel about people with tattoos, right? So this is everybody in Orange County is your population. Everybody who may have feelings about tattoos is your population, but that's not your target population. So maybe you're looking to target people specifically in who have tattoos and who don't have tattoos. So you have two groups, and you want to ask people how they feel about tattoos, if they actually have them and if they actually don't, and then in different age categories, right? So you start to become more detailed. So maybe you're curious about perceptions of tattoos by children teenagers, young adults in their 20s, middle-aged adults, and senior citizens, right? So then you explain that you are going to be collecting data on opinions about tattoos from these subcategories of people who live in Orange County. And that is your target population. So different than the population. The population is a more general term, meaning everybody in Orange County, anybody who might have an opinion, that's your population. Your target population is the people you actually intend on asking questions of, or who fit the criteria specifically for your research, who you could ask questions from. A census is the number. So sometimes we have a census and sometimes we don't. So if my population, or my target population, who is everybody who attends public school in Orange County, I could probably gather a fairly decent census by looking that information up online. I can look at what they would call a population, right? And what, commonly we would say population, but what a census of the residents in Orange County, a census of everybody who attends public school in Orange County, and then I could even make it even smaller or more detailed, more focused, a census of everybody who attends public high school in Orange County, right? So that's what you're attempting to do, is to get a census. Your sample population is the sample of people who you're actually able to or need to ask questions of. So in order to get a good representative perspective on everybody who attends public school in Orange County, you don't need to talk to every single person who attends public school in Orange County, or even public high school in Orange County. You are going to look at your census, and then you're going to calculate how many people you need to talk to so that it can be representative, meaning how many people do I need to talk to so that I can generalize to everybody who attends public high school in Orange County. And we can do so with a sample calculator. Generally what I do is I have students stop here and they practice the sample calculator. So I think I'll make an extra little side video for you guys about how to do that. And so we can talk about that specifically. Let's move on to target population. I'm wanting to write a note so that I don't forget that I promised you guys that. A target population, you need your sample through your sample calculator and a sampling frame, meaning that these are the people you're going to target from the sample size that you need to have based on your sample calculator. And that's how you're going to collect your sample. So these are the number of people. So say you do your calculations and you want a 95% confidence that you're able to generalize from people who are attending public high school in Orange County. And you know that number is, say, 360. So you would say my target population is people who live in Orange County, who attend public high school in Orange County, and it's going to be this sample size number based on the sample calculator with a 95% confidence interval or 99% confidence interval. By the way, those are the standards. And in the social sciences, it's almost always 95% confidence interval, or what we would say a 5% error, right? So you're going to have those actual numbers in there, and you're going to give that frame. And you're going to do that so that you can make the argument that you can then generalize to everybody. Okay, so magically appearing visuals. I realized I thought I had visuals up, and then so I was looking for the PowerPoint because this kind of needs visuals. So I was on stratified random sampling, so I put up a visual aid for you guys. I think this is going to be much more helpful. So stratified random sampling simply means that you're dividing your population, your target population, into groups. These are called strata, and then you are random sampling from that, right? So if you, for example, are looking at high school students, you can divide them into freshman, sophomore, junior, senior, and then randomly select, right? Simple random selection from the freshmen, from the sophomore, from the juniors, and from the seniors. That's stratified sampling or stratified random sampling. Multi-stage cluster sampling is also a form of random sampling. This one's great as well when you don't have a sampling frame, a list. And the example I give here is you are essentially clustering your groups, right, the strata, into smaller and smaller groups, and then you're going to random sample, right? So say, for example, you want to look at all of California, but you can't use all of California. So you are going to randomly select geographical areas, right? So this is the cluster sample. So I can, reduce my sample into, I'm going to look at all of California or all the United States. I pick random states. Then I pick in that state, I can pick random counties. In those counties, you pick randomly the cities. In the cities, you pick randomly the neighborhoods. And then you randomly pick the streets in those neighborhoods. And then you can randomly pick the households on those streets. And then you can interview people within those households. So that's multi-stage cluster sampling. So it offers you a form of random sampling method when you don't have a sampling frame. It works great for something like geographic areas. It also could work great for something like, like what we were talking about with the stratified sampling with the example of schools. So maybe you have one county and you have several schools in the county, so then you would pick counties or schools within those counties randomly, and then you pick the education level, so you maybe pick your freshmen and juniors randomly from those schools, and then you pick classes from those particular groups that you've done, and so you could continue to do that as well, right? So multi-stage cluster sampling. Also, kind of going back, this gives you a good idea. So you might do every nth person. So here, I pick the second person. I'm going to pick every third person then. So that's our systematic sampling. Non-random sampling options are options that we use when random sampling is not an option. We want to choose random sampling if it's possible, but many times the constraints of the research or how we're doing research or the data we're trying to collect doesn't allow us to actually do random sampling. If that's the case, then we have several options, something called convenience sampling, quota sampling, snowball designs or snowball sampling, and purposive or what we would call judgmental sampling. Purposive sampling is the same thing as judgmental sampling, but the terminology judgmental seems to have a negative connotation, so people sometimes will avoid it just because of the name. So they kind of shifted the name a few years ago and they call it purposive sampling. So let's talk about those. Convenient sampling, what they're showing here in this visual, accidental sampling, this is where you pick the people most convenient to you. So they're showing an ER here, for example, right? So say you work in a hospital and you need to ask people about health concerns. What's the most convenient? You going somewhere, going to work?
Yeah.
Okay. I thought you went the other way. That was my son with his backpack on. He's headed to work. So convenient sampling. So those people are the most convenient to you. So you're going to select people and ask them about their health concerns because you have access to those people. That causes problems, it does, with your generalizability. But it's better to get some data with generalizability issues than no data at all, because you don't have access to people, say, everywhere in the United States. Purposive sampling, oh, let's do quota sampling. Quota sampling is really easy to understand. You have a quota, you meet that quota. Your teacher tells you you need to get 25 people to do your survey, and there is no criteria other than you need 25 people. So you just go and ask 25 people, whoever you can, whoever's the most convenient. You're just trying to get that number. That's a quota sample. So that one has all kinds of generalizability issues. But again, some data is better than no data. Snowball sampling, this is the one that we often use when we have a particular target of information that we need, and we don't have a lot of access to that type of person who would have that information. So one of the examples that is often the case when people do crime or criminology, or they'll do research on recidivism, right? And a lot of times college students don't really have access to people who have been in jail and gotten out, unless they're in the field, in the job, or in your community, you happen to have friends or family who've been in jail, right? So maybe you only know one person who has been in jail and has gotten out, and you're doing research on recidivism. And so you go to that person and you ask them to take the survey, and they agree. And then when you're done, you ask them to refer you to 2 or more people that they know who've been in jail and have gotten out. And so what happens is each time you get another person, hopefully you're getting 2 from the first one, and then 4 from the first 2, and then 8 from the first 4. So you just keep, it keeps snowballing, right? So it would be actually, I think 16 from the, that next 4. So you would ask them to continue to refer. That's a snowball sample, right? It's snowballing. So if you have some kind of data or information that you're trying to gather, and you don't have a lot of access to somebody who has that type of information, you are likely to use snowball sampling, because it's the, it's the one person that you need, get you in the door, and chances are they know somebody else who has that same criteria and would fit into your target population. And so they will refer you, and that's a snowball sampling design. Purposive sampling is when you have a criteria that is so specific, you have to go hunting for that particular criteria. Now, when I was in graduate school the first time, when I was doing I have 2 graduate degrees, one in sociology and one in public policy and administration. So I would do research, field work, like market research, for extra money when I was in graduate school. It was nice because there was a lot of freedom. You would go do research, you'd ask people questions, that kind of thing. But one of the research, market research that we did, one of the examples that we did was we were asking people about hemorrhoids. Now, I didn't know people with hemorrhoids, and it's not something people talk about, right? But it was a very specific criteria. You had to have had hemorrhoids in order to be in this research target population. And so I had to go seek out people with that particular issue, and they were being paid $50 for 30 minutes worth of interview. And so it was a combination of purposive sampling and snowballing, because luckily I was able to ask my mom, to ask her friends who lived in the senior community. She got one person who was able to talk to me, or willing to talk to me, about their hemorrhoids, because of course that's a really uncomfortable situation, right? But for $50, sometimes people will do that. And so I went to her retirement community. I talked to people in the I talked to that first person, asked her for referrals, which was snowball sampling, and then talked to some of the other people who were her neighbors and her friends and asked them if they had this particular issue, and if they did, were they willing to do it? Purposive sampling. There's very good reasons to do these, and if you do non-random sample options, it does cause issues with generalizability, but we say why we're choosing a non-random sample as opposed to a random sample when we talk about the validity and reliability issues, and we explain why that's necessary. Okay, quota sampling. So quota sampling is, we kind of talked about it a little bit. You're trying to meet a particular number. But sometimes quota sampling can be proportionate and sometimes it can be disproportionate. So if it's proportionate, you're able to easily maintain the same proportion of a different group, and it's generally distributed in the general population. So if you talk about proportionate quota sampling, you want to get about half men and half women in your research project. Our population is about half men and half women, so the distribution is essentially the same. However, sometimes you're doing quota sampling for 2 or more groups, but those groups are disproportionate from the general population. Let me give you an example. So say, for example, your research is on people who fall while living in nursing homes. And you're going to nursing homes, and approximately only about 3 to 5% of the people who live in nursing homes have ever fallen down, or have had a fall recently. And so you don't want to have a proportionate number of people who have fallen to people who haven't fallen, because you're specifically interested in people who have fallen and the number's too low. So you might have a research census sample size of only about 100 people. And if it was proportionate, you would only have 3 to 5 people in your sample, in your targeted sample, who've actually fallen. But you're specifically interested in that particular criteria, so you want to increase that number. And so say you want that number to be 50% people who've fallen versus 50% of people who haven't fallen. But the population is 95% people have not fallen and 5% people who live in senior centers have fallen. So then it becomes a disproportionate sample, so that you can look in detail at that particular criteria, right? So you increase the number of people in your sample size, your census quota size, to 50% of the people that you are actually talking to. So that becomes disproportionate to the general population. You're using different proportions than the population. So on the positive side, you're going to guarantee the inclusion of usually a really small population that has that particularly important characteristic. You are able to divide equally, maybe, the sample based on that particular characteristic, but it can distort some of your aggregate results. And what you do is that you would, when you're doing your analysis in SPSS, you do a weighted solution. So you would weight the people who haven't fallen more strongly than the people who have fallen, and you're still getting the amount of information that you need from the people who have fallen. Okay, validity excuse me, and generalizability.
So this is the same visual I gave you before. We talked a little bit about generalizability issues. If you didn't watch that particular video, make sure you watch it before the sampling design or before you try to write your sampling design, because it's the background context that you need to understand in order to create a sampling design that makes sense. So the more random your selection of people, the more generalizable your sample is going to be to the population. Meaning, if you pick people randomly, all of those external variables are scrambled enough that those external variables, the ones you're controlling for, aren't going to inherently impact the group that you chose in a strong way that skews how generalizable it is, right? So the random assignment, right, the random selection of those people enhances both your internal and your external validity, meaning you're measuring what you intend on measuring, and you are able to generalize that to the population. Because it is essentially equalizing all of those pre-existing conditions, all of those things that could have happened before or outside that you can't control for. It's easier to infer then because of that, and you're able to then take it back and say, this is generalizable to the regular population. If I randomly select students from all over the United States, that's more generalizable to students all over the United States than if I only select students from my class because it's convenient. Then it's not generalizable to everybody in the United States because there's a lot of external variables or pre-existing conditions, if you want to call it that, right? That bring you guys together into my particular class at this particular school at this particular time, that will impact my results that I don't even or may not even know about. Non-random samples tend to be less externally valid, meaning they're less generalizable, sometimes not generalizable at all, but they fit much better into real-world parameters. So a lot of the time, especially in public policy, in sociology, in psychology, and when we're doing research with programs, though there's real world parameters that limit us from being able to do these completely random assignments above and beyond not having a complete list of everybody in the United States who identifies themselves as Black. You might not have a complete list of everybody plus their phone number, right? Or whatever other characteristic you're looking at. And it might be actually more appropriate for the population, right? We're not going to randomly select people all over the United States if we're doing research on people who live in a senior center and who have or have not had an injury in that senior center. Okay, my bad. I had to stop because the hammering outside was driving me nuts, so I shut my front door so I can only moderately hear. So we were talking about size with the anticipated effect. So it says the smaller expected effect, the bigger the sample size needs to be. This has to do with our confidence interval, right? So when we do our analyzation on our results on the data that we've gathered, if our sample size is too small, then what happens is the effect is so small that we're not getting accurate enough information, and so then we can't be confident, we basically can't be confident that the information that we have is valid or accurate. So you have to have a big enough sample size for it to be what we would call statistically significant. And when you run your data, you actually find out if it's statistically significant or not, because it'll tell you. There's a score for it. We'll learn about it later. I don't want to get into it now. I'll just confuse you. So if you have your population size or you have an idea of what that could be, you can go into your sample size calculator, put in the confidence interval that you're willing to do. So if it's a confidence level of 95%, your interval would be 2.5, because remember, directional, 2.5 this way and 2.5 this way. And then you put in your population and you calculate it, and it'll tell you the sample size you need. The smaller the population, the larger the portion of the sample that you need. If your population is only 100 people, you probably need like 95 people to be representative of all of those 100 people. If your population is 100,000, chances are you're only going to need about 300, 400, or maybe even 1,000 people. So you won't need almost the whole 100,000 people. So what I would like you to do as kind of a test is to look up the population of your school. So, you know, what is, and you can find this online, what is the, how many people are attending Fullerton College or Cal State Long Beach or whatever school you attend at this particular time. That's located on the school's website. You'll be able to find it. Look at what population or sample you need to be representative of your entire school. Add a 0 to that and do it again with the same confidence interval and see how it changes, and then deduct a 0. So go from 36,000 to 360, look at what you're going to need as far as the sample size, look at 36,000, which you need as a sample size, and then look at 360,000 to look at a sample size. Look at the change. Do those calculations so you could see how the population size impacts the sample size needed. So possible problems that we might have, that we almost always have: low response rate. So when you ask people in person, they're actually fairly likely to return and to do a survey for you. If you ask people via email, they're very unlikely to do the survey for you. By the way, for this, my class, you're not allowed to ask people via email. You need to talk to them in person, talk to them on the phone and fill it in for them. You need to get the actual real experience of doing field research. I do not want you to, you know, try to just send this out via email to people. That's the easy way for you. It's the, you know, I'm going to get out of having to ask this tough question, will you do the survey for me? And it doesn't give you, it gives you an experience, but it gives you an experience of being turned down, honestly. Your response rate for emails is going to be less than 1%. You have question and response variation. This is why we do testing. So people understand the question differently, they respond differently. People are, you know, likely to not be truthful, either because they're intending on lying, they misremember, they don't remember, or they're just trying to give you the information that they think that you want to hear. And there are ways that we can reduce, minimize sampling error. And so we do that through a variety of things. In terms of response rate, it's how you go about asking for a response. Face-to-face is the best. Phone conversations, you know, there's also incentives. So say, for example, your budget for this is $10. And you need to ask 20 people to do your survey, you can offer people 50 cents per survey that they take, or for each person 50 cents for taking your survey, and they're likely to say yes. Another option that students will often do is they'll buy a bag of candy and they'll offer somebody candy for taking the survey. That works very well too. Although I find that change, money, you know, 50 cents, $1, 25 cents tends to work a little bit better. Truthfulness, okay, that goes back to doing a good job doing your survey, testing your survey, and retesting your survey, and then your sample size. So the larger the sample size and the more random your sampling criteria and the method that you use for data collection, all enhance gathering the data that you want to gather. Validity, right? And so you need to work on all of those things to enhance accuracy and truthfulness. Yeah, that's it for this section. Let's see. My hair can look better. Okay, sampling design. So if you take one random sample of your population, it is expected that you will have what we call sampling error, meaning that if you create one sample for your population, the chances that you're going to be accurate in representing that entire population when you generalize is going to have a certain percentage value. Your mean or your average is going to be off from the population average if every single person was surveyed or questioned or data was taken from them. So how do we resolve this issue? We don't actually question or gather information from every person in the population in order to generalize. What we do is we take multiple samples within the population, and then with each one of those samples we do our we take our mean from each one of those samples, and then we take the mean of means. And what happens is that mean of means from that variety of samples is often very close to the actual mean of the entire population. So when you do something, for example, with vaccines, and they were doing samples with vaccines, and so not everybody was tested with vaccines, but there were multiple sample groups that were tested given the vaccines, and then the averages from those groups were taken, and then they were averaged out from all of those groups, and they did it in such a way that they were able to generalize to the entire population that this was the kind of problems that they would have or not have, or the likelihood that you would have medical issues, or that it would protect you from, say, coronavirus, right? They know this because they have done samples, multiple samples within our population, and they've taken the average of averages. So the frequency of the raw score can be obtained from both your samples and your populations, and it is usually much more economical to do so from multiple samples than from the entire population. So I posted up here, some kind of throwback to intro to statistics. Here is our mean, our median, our mode, and our range, right? So a mean, this is what we think about when we say an average. This is what we mean, right, is a mean. So add all the numbers and divide it by the amount of numbers. It's an average, right? So that's a mean. A median is the middle. So a mean is an average, a median is a middle. You order the set of numbers from least to greatest, and then you take the middle number or the middle two numbers. So the median for this 1,33689 is 4.5. If I took out one of those threes, if it was 13689, our median would be 6. Our mode is the most common number. So 931,836, our mode is 3 because there's 2 3s. So mean is your average, median is your middle, mode is the most common. A range is the difference between the least and the greatest. So the range is you look at the highest number and the lowest number and highest number, and then you look at the what's in between those two. You basically deduct one from the other. That's your range. Back to the basics. Okay, so we don't have to work too hard on this, but I do want to give you a general idea of sampling distributions. So a sampling distribution is the distribution of all of your samples. We were talking about that before, where I showed you the circle within the circles, right? The circles within the circle. So you're going to take a large number of random samples. So you take more than one sample from your population. And then you are going to do your
mean for each one of those samples. You're going to put them into into a graph so that you can approximate a normal curve. So you want to take enough random samples so that it actually starts to approximate a normal curve from least to greatest. And by the way, this normal curve happens in every single thing that you can put into a statistical variable if your sample size is big enough. You know, I can have a normal curve if I look at all of my grades, everything else being equal, you'll see a normal curve in grades. You will see a normal curve in people's opinions. You see normal curves in all the physical sciences. So from people's sizes to, you know, things within, you know, like maybe iron content in dirt, you know, everything, if you take a large enough sample size, eventually becomes a normal curve, which I think is fascinating, but you know, I'm a nerd. Okay, so you would take as many samples as you possibly can, big enough so that you eventually approximate that normal curve, and then you're going to look at your mean of means, right? And that should be equal to your population mean. And then you look at your standard deviation and of your sampling means, and it should be smaller than the standard deviation of the population because it should be more stable. So if you take a variety of samples, a large variety of samples from the population, the count from lowest to highest should be smaller in your samples than in the normal population because you're not going to have as much variation in your mean of means than you would in your entire population. So a sampling distribution of means, this is what I was talking about here. So here's all your samples, and so you would take your average, those are your means, and then you look at your distribution. Okay, where was I? That was my hubby calling. I like to answer because he always answers the phone when I call. And so I try to be very careful to do the same and to be as respectful to him as he is to me in that regards. No matter what he's doing, he answers the phone, and so he's so awesome. Okay, so where were we? Oh, sampling distributions and means, right? So you take a large number of a random sample drawn from that population, and then you look at that sample distribution of means, and it should approximate a normal curve. So you were probably wondering when I was explaining this, how do you know that your sample population means actually approximate the real population mean if you don't take that real population score, if you're not actually pulling data from everybody? How do you know? How do we know that it's the same? We know because if it's done accurately and if it's large enough, it will turn into a normal curve. That's how we know that it's the same. It'll approximate that normal curve. So the mean of sampling distribution of means, the mean of means, is equal to the population mean. And we know that because it approximates the normal curve. Our standard deviation, right, the least to greatest, that number in between of sampling means should be smaller than the standard deviation of the population. What that means is that it's actually more stable or more accurate or more representative with less error than if you were to take a whole sample. Okay. So creating and collecting data. I like to use, so when you do your statistical analysis, you can run a Chromebax Alpha, and it will tell you how much each one of your items is measuring of the variable that you're trying to measure. So we were talking about internal validity here.
So internal validity is you're measuring what you intend on measuring. And the way that we get internal validity is that we write a very concrete, concise, well thought out, very descriptive definition of our variable. If you are in the hard sciences, quote unquote, right, this is pretty easy. You know, a table is a table, you write the description of it, it either is or it isn't. But what if you're talking about something like honesty? That is a concept that can have a definition, but is so loose and ambiguous. You can say, yeah, honesty, I know what that is, but your definition and my definition of honesty are two different things. So you had to write this probably really uncomfortable definition for you, right? This writing style. You had to conceptualize your variables. So whenever you're in the social sciences, that extra step of conceptualizing is much more additional work than in what we would say other sciences, where those variables are fairly concrete, right? So, you know, if we're talking about something like, you know, dirt or an animal, soil, whatever it is, those definitions are fairly concrete. You could usually find that definition somewhere and then use that to create your own definition, your own conceptualization. A lot of times that step is even skipped in other sciences. In the social sciences, you have to make that thing that's not concrete, that concept that's ambiguous, into something concrete. Now, you have the power to do so. As the researcher, your definition is the definition that stays. You have to say what it is, what it's not. You might gather information from other research to help you define it. So that would be here. So the example here is somatic focus and activity avoidance. So they created a definition, and then each one of your questions that you're going to ask about it, here we called them items, item 3, 5, 6, 7, 11. These all ask about somatic focus. Questions 1, 2, 9, 10, 13, so on, all talk about activity avoidance. And we can actually run a measurement to see how much each one of these questions are measuring our variable. So now we go back into that conceptualization, and in your workbook you'll see kind of an example of a conceptualization and how the student looked at one sentence and created a question that measured that one sentence in their conceptualization. Then they created the next question that measured the next sentence in their conceptualization. So when you start to see fluff, things that were just added to create an essay or to add words, those things need to be deleted. And then, you know, things that are missing, the definition, those concrete steps in your definition probably need to be added. And so when you create your survey, you need to think about it from this visual conceptualization. Here is your first conceptualization or definition of your IV, and then here's the conceptualization definition of your DV. Each one of these questions needs to measure a portion of it. This is just another visual aid to kind of help you with that, right? Concept conceptualization, all the questions that are connected. A DCI, data collection instrument, I've used this terminology quite a few times, so you probably have gathered what it means, but it's simply a common terminology that's used for any type of instrument, usually non-electronic, that you would collect. So anytime you would create a table, a survey, an observation, measurement, scale, or directions, all of those things are DCIs, data collection instruments. And so we use them for creating data sets, usually well, they're used for collecting data so that multiple researchers can have the same rules or ask the same question. We use them so that we have consistency over time. Basically, data collection instruments increase reliability. Reliability between researchers. So if there's more than one researcher, they're asking the same question in the same way. If you're doing a question once today and then again tomorrow and the next week or next year, you're asking again the same questions in the same way. So it increases internal validity. Okay, so where are we in the research process step? Says sociological, but this applies to all social sciences. So you identified the problem, right? So you have your research question, you reviewed the literature, you formulated your hypothesis, and you gave both conceptualization and operational definitions to your variables. And then you are now currently in section 4, choose your research design or method. So we're doing our sampling design and our research design here.